Everyone, welcome back to my channel Learning Math with Shelly. This is my second video on the topic vectors, and in my first video I just gave a description about how to find the vector equation and parametric equation of line in 2D and 3D. Basically in that video I described the way how to derive that equation, and in today's lesson we are gonna working on some questions, and while solving those questions I will be giving you some tips and tricks which are very helpful. So please watch this video till end and you will be learning a few points for sure. And I request everyone, whichever country you are from, I want, if you are learning anything and you find any doubt in the video, if you don't understand any point, please write me a message. I will be sharing my phone number as well, and you can comment in my videos as well. So here is the first question. If you see, the question is, describe each of the following lines using vector equation and parametric equations. So here we have two questions. I will be going to explain one of these questions. So the first question is a line with the directions -1, 2 and which pass through 1 and 4. So what I'm gonna do, I will be solving the first equation with the vector form. So you will be doing the parametric form for this one. And for the second question, I will be doing the parametric equation. Vector equation you can do. Okay, so the first question is, you have to find the line of the equation. You have to find the equation of a line, sorry, with the direction -1 and 2, and it is passing through 1 and 4. So it is very important for you to see which is the point and what are the directions. So we know the equation, the vector equation of a line is given by like xy, which is our general point. Why I'm taking here only xy? Because the point is given as like x and y coordinate only. So this is equal to the point, and the point is like 1, 4. So be very careful, do not interchange these two. Here 1, 4 is the point, and then plus lambda times the directions, which is -1 and 2. The order is very important. So this is the vector equation. Okay, now this is the vector equation. So parametric equation you can find by yourself. Now the second is 1b. Here I will explain, let's say, the both ways, because if I want to find the parametric equation, I need to find out the vector equation. So what they are saying here, a line is passing through this point 5, 2. So I know the equation is written as xy, the first point, whatever I know, that is given here like 5 and 2, and plus lambda times a vector which is the line is parallel to. But here the question is, they said the line is perpendicular to 5, 2. So 100% I cannot write. If I write this, it will be wrong, because here let's say this is the equation of a line. The direction vector, which is called like b, it should be parallel to this line. But here what is given, the line is perpendicular to this vector which is having the coordinates like 5 and 2. So I cannot consider this one. Okay, in this case what I need to do now, what I have to do, because they said perpendicular to 5, 2. Now the thing is, let's assume the direction vector which is parallel to this line, that is b1, b2, and there is a line whose the line is perpendicular to these direction vectors. So we know if the two direction vectors, they are perpendicular to each other, the lines direction vectors and the another perpendicular direction vector like 5, 2, if they are perpendicular, so that means the dot product, or you can say their scalar product, that would definitely be equal to a 0. Okay, it's a simple scalar 0, it's not a vector 0, it's a simple 0, because dot product is also called scalar product. Why? Because it generates a scalar value, a simple scalar number value without any direction. So that means if I open it like a dot b, okay, so here I know the coordinates. So b1 will be multiplied by 5, which is 5b1, plus b2 multiplied by 2, which is 2b2, and this must come out 0. Now there are so many different possibilities, but one of them is 5 and here is 2. If I want them to add and the result should be 0, so that means one of them should be positive and another should be negative. So what I do, I take this as negative 2, because here it is 2 and here it is 2, I will multiply it by 5. So in this case it will produce a result of a 0, because it will be negative 10 plus 10. So as a final result, what I can say here, that the ratio of the line, this line will be given as x, y, and this is equal to 5, 2, and the direction vectors I will be giving as lambda times minus 2 and 5. So this is the vector equation. And if I have to give it as parametric equation, just one single step we have to do, that we have to do for x and y both. So x is equal to the x value here and here. So it is 5 minus 2 lambda, where lambda is a scalar, and y is equal to 2 plus 5 lambda. These are the parametric equation. Okay. Now the next question comes here. Okay. So here the C part of the question is, we have to find the equation of a line which is parallel to 3i plus 7j. So basically again here we have given a vector, and our direction vector I am showing it with B, because I usually write the equation as r is equal to a vector plus lambda vector b. So my b here I will consider it like 3 and 7. This I and j, these are the special vectors, and I want you all to comment me that what they are called. These are very special vectors. Okay, you have to tell me what special is about them. Okay, now the question is, we got the equation, we have to find the equation of a line which is parallel to this one. So we have the direction vector which cuts the x-axis at -6. If it cuts the x-axis at -6, so this way, here let's say it is -6, so what will be its coordinates? -6, 0, and I am taking only the x and y because it's a 2D. So what I will be writing as a final equation, I'm gonna write only the vector equation. So r is equal to -6, 0 plus lambda times, where lambda is a scalar, 3, 7. Okay, so this is done. Now D question, I believe you all can do it. Then E and F, there are two questions, and these two questions will be giving you a very good point, and that is called non-uniqueness of vector equation when the 2 points are given. Okay, when 2 points are given. See, so far the questions which we have done, there were given 2 points. One is the point, the coordinate point, and another piece of information which was given to us, that was not another point, but it was direction vectors, or a relation of direction vectors, like it's perpendicular to line or it's parallel to line and so on. But now the question which is given to us, they are saying the line is passing through this point and this point. Now in this situation, what should I do? I draw a line, and one point is 3, 0, let's say it is this point, and another point is 7, 2, let's say it is this point. Now you need not to draw the exact like coordinates, it's just a random idea. It can be like this actually, one is 3, 0 and the another point is 7, 2. Okay, now the line is passing through these points. Direction vector I can consider this way, or direction vector I can consider this way also. So I will be taking both the conditions. First, in the first example, I am taking it only in this going direction upward. So let's say this is my point A, and this is point A, sorry. So A is 3, 0 and this is my point B. So if I am taking the equation of line, it will be R. I am taking a point A, so it will be 3, 0 plus lambda times, I need this direction vector. If I am taking this direction vector, so it will be like B minus A. the OB minus OA you can say, because we always subtract the position vectors. OB minus OA, so that will be 7 2 take away 3 0. So what I got from here, 7 take away 3 is 4 and 2 take away 0 is just 2. So this is the one equation. Now another way what I can consider, that I am taking the line the same way, but I am taking the direction in the opposite form, like this one. So I am taking, this is my point, so I will start R is equal to 7 2 plus the points I am taking, this is my point A and this is my point B, so it is basically lambda or theta or anything like that, times A minus B, OA minus OB. This is a way to find the direction vector. If you see, if you know the 2 points on a line and you need to know the direction vector, so it is just OB minus OA. So what I will be doing here, this is 7 2 and I have to find out BA, so it will be 3 0. So I will be writing here 3 0 minus 7 2. So I will be getting here minus 4 and minus 2, but still they both are parallel vectors, they are just in opposite direction. So this will be the final equation. And see, there are two equations here, two different equations. So these are non-unique equations, because here I am considering this point 7 2 and here I am taking this point 3 0. So you can get different vector equations. Now this question number 2, a line is passing through 4 and negative 3 and direction vector is given. So this is a quite simple question. Here they said you have to write the parametric equation of the line using the parameter lambda. So if they have mentioned in the question that it should be lambda, we have to follow that one only. So equation is quite simple. R is equal to 4 minus 3 and then plus lambda times negative 1 2. They are saying parametric equation, so it is x, y, 4 and negative 3, that is the point, and this is lambda times negative 1 2. And now I can write the parametric equation, it is 4 minus lambda and y is equal to negative 3 plus 2 lambda. In the second part of the question, they are asking us to find the points on the line with lambda 0, 1, 2, negative 1, negative 3. So just these are the points, x comma y is a point on the line. So basically I need to find out x, y for different lambdas. So let's say I am taking lambda as 1. You have to do it for 0 also, for lambda 2, lambda negative 1, lambda negative 3. So if I take lambda as 1, so x is equal to 4 minus lambdas, which is 4 minus 1, so 3. And y is equal to negative 3 plus 2 times 1, which is negative 1. So I will say the point on the line will be 3 comma negative 1. So these were some of the basic questions, but here I tried to cover some important points. Please do comment in the comment section and let me know how the video you like. Is it helpful, or how can I make it more useful? And please let me know. I will be waiting for your comments. Thank you.